Chapter 1, Section 7, Light Microscopy and the Discovery of Microorganisms. Now, microbiology itself, micro meaning small biology, study of life, really couldn't occur before the microscope. Think about it. Many of the things we're going to be looking at, we're going to be discussing, are too small to see with the naked eye. Now, these original microscopes that individuals like listed here, Hooke, Van Leeuwenhoek used, were basically extremely rudimentary. Very low magnification. But it allowed these individuals to see things that were too small with the naked eye. The ground glass lenses weren't anything we would scoff at. Some of our magnifying glasses you played with as kids had better manufactured lenses than they were using. But you look at Hooke. Hooke was the first to go through and describe microbes, things that were too small to see. People just didn't believe him. He had to show them, hey, look, that spot you see on the bread that you think is one growth, one thing, is actually hundreds, if not thousands, of small things all packed in together. Van Leeuwenhoek went and he was the first to see what we would consider to be bacteria. Hooke was looking at molds. Van Leeuwenhoek, well, he looked at bacteria. He looked at what was swimming around in mud puddles and lakes and streams and different things like that. He kept track. Here's what I see. Here's what I think I see. Here's how I think things are moving. I mean, you look, here's a picture of Robert Hooke's microscope. It has, place where you put the drop or put whatever you wanted to look at. Light source that came through, bounced off, lit up what he was looking at, and then he would visualize. In my opinion, this is more of what we would think of as the dissecting scopes that you played with upstairs, or played with in 215, maybe in 211. Because instead of light passing through what he wanted to look at, it bounced off and he could see visually. Here would be the objective lens. Here would be an ocular lens, maybe. This tunnel here. He could maybe adjust for better, put things into focus, but it was very limited on what he could do. Here's a reproduction of some of his sketches. What he thought, looking at with the naked eye was just a dot on bread. He was the first to show that no, like I said, this is a bunch of little things growing together. So packed into us, they look like a singular dot, but it's a bunch of what we would now think of as vertical asexual hyphae coming up off the surface of the bread, the surface of the fruit, whatever. Van Leeuwenhoek took a different approach. Instead of, the tube-like that Hooke was using, he had this contraption. Ground glass lens there, very small, that little aperture there. Had a needle here that he could focus, that he would put a drop of something on, and then he would use, different screw methods to move it up and down, backwards and forwards, to try to get it into focus. He would hold it up to the light and he would peer from the other side through that little lens. You'd hold it like this and look at it, holding it up to the light. He saw small little things. Here's his, reproduction of his sketches, and he watched as things moved. Now, in my mind, I look at this, was he looking at actual bacteria or was he looking at, small protist? Don't know. But he was the first to see them. He was the first to sketch them. He was the first to take notes on how they moved, what they did. Van Leeuwenhoek's microscope was, what we would think of as traditional light microscope. He bounced light through what he wanted to look at. Now, keep in mind the magnification on either Hooke or Van Leeuwenhoek's was minimal at best. Maybe a few X resolution, nothing great. Or, I'm sorry, a few X magnification. Resolution. Resolution is how crisp, how in focus is what you're looking at. Yeah. I mean, there is, no matter, unfortunately I have to say that the more money you spend, the better the resolution will be. But there is a limit. A lot of it's going to have to do, quality of the glass you're using for your lenses. How were they made? How were they manufactured? How were they ground? What are you using as your light source? What kind of bulb? Things like that. For, your specimen that you're looking at, what kind of glass or plastic slide is it on? High manufacturer, low manufacturer quality will affect just how, magnified you can go, but still maintain a crispness for focus. Because you can take any microscope, even the ones you're going to play with in 211. You can magnify them, as far as the lenses will allow, 1000x. But the resolution, you can't get it in fine focus. You can't get it crisp, because at that high magnification, everything will still look fuzzy. Higher end light microscopes, better glass, better light source. Well, you can take it up a bit. It's still going to be slightly fuzzy, but it's going to be more crisp. But there is a limitation. To go at high magnification and get high resolution, well, then you're going to have to go, forget light microscopes. You're going to have to go to laser microscopes. When you look at the type of microscope, bright field, phase contrast, dark field, fluorescence. The microscopes you're going to be playing with in lab are what they refer to as bright field. Okay, light just comes up through the bottom. You can control how bright, how intense the light is, using a knob or rheostat to turn the light bulb on high, turn the light bulb on low. And then there's an iris that can control just how much light gets through. And that's about it. Phase contrast, dark field. This is means of passing the light before it hits your specimen through different filters. So instead of the chaotic, here's all the different ways the photons are coming off the light bulb for bright field. You can use filters so that instead of the chaotic, now everything's coming in a specific light path. Only the photons that are coming in like this direction can now pass through. It will change how your eyes perceive the light, as opposed to chaotic, where things are like this and just bombarding around. And it's like this light here is very chaotic, and my eyes can't really look through it so much. But if I put a filter here and only certain paths can go through, still be a bright light, but it's less chaotic in my eyes, and I can see it, I can perceive more. Two sets of lenses. Objective lens, that's going to be the one that's closest to the slide. Generally what you're going to see is a 4, a 10, a 40, and 100. 4, 10, 40, 100. The ocular lens, which is the one that's up by your eye, for all intents and purposes, that's generally going to be a 10x. Yes, it says, the textbook says 30, and those are going to be from some higher end microscopes that have specific uses that aren't going to be seen in a lab like ours. To get total magnification, whatever your objective lens you have it set to, the 4, the 10, the 40, the 100 times the ocular. So it becomes 40, 100, 400, 1,000 is going to be the final magnification. Ocular lens up here, 10. Here, 4, 10, 40, 100, which is what ours has. This one's probably just 10, 40, 100. Why doesn't everybody have the 4? Well, because honestly it has limited use. I like to use it just so, I can find where things are on the slide, and then I start going up the magnifications to get things up to the 1000x is what you're going to need if you want to look at bacteria. Bright field literally just means all the light comes through. Now, thankfully, these bacteria, these microbes, this is some form of a protist. I'm not sure what this is, so I shouldn't say bacteria. Are pigmented so that you can see them. You don't have to stain them. They are readily, easily seen. Smaller things are going to be harder to see if you're using bright field, so then you have to control how much, light intensity, how, on the rheostat, do you have it on low, do you have it on high, and then the iris, how much light are you actually letting through.